Mechanical properties of solids. Topic Hooke's law. In the last two videos, we have seen that when a body is subjected to a stress, strain is produced. For small deformations, the stress and strain are proportional to each other. This is known as Hooke's law. So, Hooke's law is valid for small deformations. That is when the given stress is very, very small. In that region, stress and strain are found to be proportional to each other. Mathematically, we have stress is directly proportional to strain. That is, stress is equal to a constant K into strain, where K is the proportionality constant and is known as modulus of elasticity. We will discuss modulus of elasticity in another video. Hooke's law is an empirical law and is found to be valid for most materials. However, there are some materials which do not exhibit this linear relationship. Now let us discuss Hooke's law and its experimental verification. Hooke's law is for a small deformation when the stress and strain are proportional to each other. It can be verified in a simple way by stretching a thin straight wire of length L and uniform cross-sectional area A, suspended from a fixed point O. A pan and a pointer are attached at the free end of the wire as shown in the figure. So that is the experimental arrangement to verify Hooke's law. The extension produced on the wire is measured using a vernier scale arrangement, and the stretching force can be calculated from the given load. A graph is plotted using force on the x-axis and delta L on the y-axis. We will get a graph of this shape. For large forces, it is seen that the points deviate from this straight line. So for small force or corresponding to small stress, it's a straight line, meaning the force and the stress and the corresponding strain are proportional to each other. Let us verify it. From this graph, we have delta L, that is the change in length, equals slope of this graph into force. Multiplying and dividing the above equation by volume. If A is the area of cross section of the wire and L is its original length, then its volume is A into L. When the wire is stretched under the effect of that stress, length increases but volume of that wire remains the same. So we get F into slope equals AL into delta L divided by AL. So AL is the volume, so dividing and multiplying by AL, there is no change in that equation. So F slope is equal to AL into delta L divided by AL. On rearranging, we get F by A equals L divided by A into slope into delta L by L. For a given case, L is constant, area of cross section is a constant, and slope being another constant, L divided by A into slope is a constant. So we get F by A directly proportional to delta L by L. By definition, F by A is stress, delta L by L is the corresponding strain. That is, the stress is proportional to the strain in the elastic limit. Thank you.